Ever wondered what's make your favorite wire, car, testing, or how that school lady gravity moves? Something of the secret science, sometimes called our DC electric motor. Now the DC stands for the direction, which is charge of electricity that flow in the one steady direction, like from a battery. In this video, we are going to take a super simple look at what these amazing little machines are and how that work with their magic to create motion. So get ready to see how electricity can be tuned into the spinning powers. So let's rewind. So how does the electricity actually make things? All thanks to a clever interaction between the electricity and the magnetism. You probably know that the magnets have the two ends, the north pole and the south pole, and at pole rebel each pole each other while the opposite poles attract. Now when we send the direct current coils or a wire inside the motor, this will become a temporary magnet that creates its own north and south poles. Inside the motor, we usually have a permanent magnet fixed in a place. So what happens when our temporary magnet is coil? It goes to the permanent magnet. Exactly. The opposite pole attracts. That opposite pole attracts, pulling the coils in the one direction, and the like pole shift, pushing it in the same direction. This creates a spinning force, which we call torque. And if you know that the torque have an ability to move, rotate that armature. But if it is just system and stop, what would be very useful? So DC motors have a special part or a communicator and process. This clever campaign acts like a switch. Just as the coil completed half a turn, the commutators and the presses reverse the direction of the following through the coil. The reversal of the current also places the north and south pole of our temporary. Now the poles are in the perfect position to be pulled, keeping the coil spinning continuously. It is like constantly giving a little nod in the right direction. So in a simple terms, electricity flow in the motors. The electricity makes a coil of wire act like a magnet. This temporary magnet interacts with the permanent magnet, creating a spinning force. Commutators and brushes act like a switch, continuously changing the current direction to keep the spinning going. And that's the basic idea behind how a DC electric motor turns electrical energy into the rotational motion. Pretty near. There are the different types of the DC electric motors designed for the various jobs, but they all work on the same fundamental principle of electromagnetism. In the next part, we will explore some of these different types of wires. You might find them in action. Okay, thanks for watching.